Right, so it's now time for the next part. So if I carry on assuming that this signal here is kind of okay, and assume there's a documentation difference between what's actually there and what I'm seeing, or what I'm seeing is close enough to documentation to actually be correct. If I move on from that, I'll just carry on. Since I'm unsure about that, I've got a noting for it to say, hey, something's a bit weird here, and I'll move on. So the next step is to make sure I've got trigger internal, circuit mode auto, that one there, range hold off. Right, set it on. Now it should be it says, can level changes be observed at A8 U16 get probe and pins 2, 3 and 6. My unknown is changed from open to short, so I need to get a jumper set up here. Where have I put it? There it is. Can't see it. On each function. So open to short, auto reverse for each function. Okay. So I need to check for level changes 2, 3 and 6 between open and short on each range. That's a lot of checks we'll do, but that's okay. U16 is where? 13, 14, 15. That should be 16. There's a number there, 16. So I'm looking at pin 2 first. God, if I'm kind of slipping off. It's always a risk with these things, just slipping off. Right, 2. Okay. That's doing something. And I'll change ranges, or change functions. That's doing something. It's just, I don't know, how's it correlating? Well, it's doing something. It's going up and down by 5 volts. Let's just increase this. Other way. Yeah, I mean, I don't know, is that, it's not necessarily tied to whether this is high or low, so let's try resistance. Okay, yeah, so it ties better to resistance than anything that's going through the ranges. That's alright. So that's pin 2. Let's check pin 3. Again without slipping off. So resistance is doing that. God. Get on there. So yeah, that's working on resistance. Capacitance. That's doing something. And inductance. So the capacitance on that one there looks a little bit interesting. If it's open, it's going between up and down. Is that right? It's doing that square wave there, but I've unplugged that, so it's not short anymore. There's no difference there. Now it's gone low. So it's like it's hunting the ranges. So yeah, I suppose you could say it's changing. Right, so same thing for pin 6. This is a 7-pin device, is it? Yes, so pin 6 is that one there. So it's currently sitting high. Unplug it. No difference. No difference. Now that's interesting. That's always high. Aha. Okay, inductance. I can hear it ranging, but nothing's happening. That's always high too. Resistance. This is a sign of a problem. Assuming on the correct pin. So U16, yes, on the correct device. 1, 2, 3, 4, 5. Ah, hold on a second. 1, 2, 3, 4, 5, 6. Now I'm on the wrong pin. I was on pin 7, not pin 6. Let's do this again. Okay. Yep. So I think these are probably range signals to control the relays or something like that. So that's doing something at least. Inductance. Searching. Then it stays high. Plug it in. Short it out. Goes low. Now I would have actually thought there'd be issues with this part because it does have trouble ranging. It can't actually find the values. Don't know. Anyway, that seems okay. So that's what's supposed to do, so I can move on to the next part. Okay, the next part is talking about checking the A3 card for signals which match the ranges. So I think I'm going to skip that because I've already got the card in this one. The next stage is back to this card again. So I've been taken it out and came to here, then going back. Because these header riser cards I've got in here are really tight in the sockets. They're actually a bit too thick, I think. So they're quite tight. So I don't want to keep taking them in and out. And if I can avoid it, I don't want to risk damaging it. So I'm going to stick with this card for the time being. So I'm going to skip that step and go to the next one, which is back onto this card here. So what it's looking for is logic levels being observed at TP3 and U15 pin 9, TP4 and U15 pin 4, TP5 and U15 pin 7, respectively when LSC 0 signal is at high level. Yeah. Yeah, okay, so the LSC signal was supposed to be found at A3 TP1, which should be at the top here somewhere. I think it's that one there. It might not be that one there. Let's get top. God, drop that. Oh, it's TP1. So, yeah. I'm not seeing a high level there, I'm seeing a almost low. Saw a pulse there. Yeah, I don't know. Anyway. Oh, it's nice, I had that on DC bias. Let's recheck this. In case that matters. That's looking kind of what you expect. Ah, look at that. That's the pulse I'm supposed to be getting there. What's different there? What is different there? What did I change? This. That? No, it wasn't that one. Something's different. Interesting. Okay. If I do an inductance with an open, it should be the same. I'm getting quick pulses in now. Oh, I've obviously did something right. I don't know what it was, but that's something. I know it's looking kind of right, I suppose. they are like consistent square waves. At least they were. Depending on this range thing. That looks kind of right, but yeah, that's what it is, isn't it? Look at that. There we go. That's right. All right. So right. Anyway, what I was doing. So TP1. That is not really doing a lot, is it? Occasional pulses, but there is a voltage level there, which is 560 millivolts. Right. I'm not sure that's right. I don't know what I'm supposed to be getting, to be honest. Well, let's check U15 pin 9 and see what we're getting there. So that's 15 pin 9. That's in there. That's an 8 pin. So that's pin 9 there. No, it's not. It's pin 8. What I'm doing. Pin 9 is over here. So yeah, there's pulses. It changes when I'm plugging it in. Yeah, it's doing something. Is it right? I've got absolutely no idea. Yeah. It's changing for each type, so that's doing something. TP4, which was that one. I've already done a check, haven't I? But then it said, respectively, when that signal there is at a high level. Well, I haven't seen that signal at a high level. Maybe that's a clue. Right, so TP5 done it, and 15 pin 7. So pin, is it right? Hold on. Yeah, pin 7. 2, 4, 6, 7. That's pin 7 right there. It's pulsing. Right. Let's get it on better. Not sure that changed or not. Let's try that one. So short pulse, long pulse. Okay. Now unplug it. It's going to short pulses. Yeah, that is changing. Let's try this one. It's doing long pulses, short pulses, long pulse. Seems there must be a reason for those ranges. And that did change the short pulses when I plugged in. So that seems to be doing its thing. Okay. Well, it's just that LSC 0 signal, which is supposed to be at high level, but I haven't found that yet. So maybe I do have to go to this card here. The next step is also for the A3 card, so that's what I will do. I will now transfer to the A3 card and see what I find. Okay, so I've got in the riser card, so I need to check for an LSC 0 signal or LSC0, I'm not quite sure which it is, at TP1, which is this one. I've already played the scope a little bit there, so yeah, okay, that's showing a pulse, which wouldn't show up on the rolling display. And I need to check U4 pin 4. The U4 is on there. Pin 4 is here. Should be the same signal in theory. Yeah, there we go. There's a pulses there. So yeah, that's working. So So I need to go to the next check, because this is the check I skipped before. I'm guessing the LSC 0 signal is correct. I mean, I don't know what I'm supposed to be seeing. I should actually see if I can find what it referenced as anywhere. Let's just have a quick look. I don't see a reference to it anywhere, what it's supposed to look like. Okay, we'll move on to the next bit, which is to check U10 pins 4, 6, 8 and 10 in different modes. I'll use a bit of this stuff to try and lubricate the riser cars so they go in and out a little bit easier. Let's see if it works. Now, so I've got to check for inductance and capacitance ranges. I'm currently in inductance, and I'll do it left to right, so it's capacitance first. As a short, just get into that lead. A bit tangled up here, too many wires. Come on! I hate, why is it always tangled up? Always. Right, shove that in there. So it's a short. So you've got to do parallel first. So now I've got to check on these pins to see what's going on. And, oh man, I've got to tidy up this desk again. Right, so pin 4 of U10. Where's U10? Here's 11. So that's probably 10 under there. Yes, it is. So pin 4 of 10, which is over here. Almost like 7 to 9, isn't it? So there's something going on there. Let's bring that down so I can see. Okay, let's just roll it. Do a fast roll, shall we? Alright. So yeah, that's doing something. Can logic signal be observed? Oh yes, there's definitely logic signal there. And pin 6. Well, it's a high. I'm pretty sure I'm pin 6. 2, 4, no, that's 5. That's 6. That's a logic low. That's correct, sorry. I just got a chart, this is what it should be. So yeah, that should be low, that's fine. So pin 8 over here. That should be pulsing again, yeah. It's got a couple of pulses there, which is interesting. That's high low. And pin 10 should be pulsing as well, looks of it. And it is. So those look right. I've got the same test again in serial or series. I'm recording everything because some people may want to reference this. So in series it should be going high and low, that's correct. Pin 8 should be low, apparently. It is. And pin 10 should be going high and low as well. It is just much slower. That's okay. So that's the capacitance shorted out. So now to do inductance with an open. I'll do the same sequence again, so parallel. So do it again. Pin 4. Yep, that's pulsing. That's correct. Pin 6 should be pulsing. It is. Pin 8 and pin 10 should be both below. So 8. Yep. Pin 10. Yep, cool. So it says already on pin 10. Let's flick this over to serial or series. That should be pulsing. Yep. Pin 6 should be pulsing. It is. Sorry, pin 8 should be pulsing. Pin 6 should be low. appears to be, and pin 4 should be pulsing. Yep, so those look fine. Can't fault those either. It's getting annoying, so I definitely got something wrong with it, but I'm not finding anything actually wrong in the test, am I? There's only a couple of things I've not been sure of. Right, so I'm looking at this manual here for the next stage of testing. So this is section 8.3. Just trying to go through various bits. Now, when I did the original testing, I observed that in the inductance range, I was getting a what I thought was an error reading. But if you look at the chart here, as I've just found this chart, I didn't see this before. This is for test 1. This is exactly what I was getting. I was getting that correctly. That was fine. And then I didn't notice the decimal places, but yeah, so I should do the 1 kHz and 120 Hz tests again, and just make sure that I'm getting the same decimal places coming up, I suppose. But that matches up with what I was seeing. So I go to capacitance as well, and what was I getting that one there? The 2000 PF range series mode was giving an error. So let's have a look. PF range, there we go. Out of range, blanked up, blank. Yeah, that's correct then. I'm chasing an error which may not be here. That is what I got. Resistance. Let's see how we go here. Now let's go, it's a bit bigger, this is still test 1. Resistance I got, I'm looking at my notes here, 2000 milliohm, parallel failed, series is okay. Series okay, parallel, milliohms, yeah, okay. Yep, that was fine. And this one here also had earlier in test 2, yep, test 2, kilo ohms, mega ohms, kilo ohms, potentially I've got mega ohm, definitely I've got mega ohm, and 200k. I think I had 20k as well at one point. Yeah, so yeah, that's series resistance mode. Yeah, that is matching up as well. And on inductance range, I had 3 ranges which weren't matching up. Yep, those ones there. 20, 200, 2000. Yeah, that's, yeah, those match. I don't know if I saw zeros though. So I need to check this section here, unknown, as a short on the inductance range, checking for these readings and these readings. That's the difference there. Okay, so that's what I need to check for, is that, using test 2. But these out of range ones, which is what I thought was an error, they actually match up. Capacitance as well. What have we got here? 2200. That's what they would be. That would be 20. Well, I've got MF written here, not microfarad. Oh, that's MF, that one there. There we go, that one there. So that's the open circuit. That matches that one. So yeah. So I just need to check these values here and see if I get those again on test 2. Now that you've got a chart showing what it should be, I can go back and relook at that. That may not be an issue. It might be a bit of confusion there. Okay, so I'm going to go back and do this test 2 again. See, as I've just found those charts which actually show what display should be showing, instead of me having to guess what should be there. It wasn't very clear originally. So, right, test 2. Flick that over. I'm going to do manual triggering and do resistance first, I suppose. So let's do. No, it's not inductance. Do it in a sequence that's shown. Inductance with a short. So let's do that. And maybe we'll do internal automatic triggering. Inductance with a short. Henry, so microhenry, millihenry, all showing 0, 0, Henry, 0, 0, 0, out of range, out of range, out of range. These are interesting. There's some differences here. So, okay, let's step through them. So, microhenry first. This is supposed to be 1000. It's got minus. Aha. That's different. So, it should be 1000 plus or minus 5 with the dissipation display showing 0, 0, 0 plus 5 minus 0, and there's nothing there. So is this voltage related? Let's just step through ranges, isn't it? So range hold on. Nope. Frequency? Nope. So step back through these again. Start back at the beginning. Oh, did I go too far? No. So microhenry. This is not right. Series inductance. These aren't right. So millihenry, 10 plus or minus 5. Well, no. Again, no. This is just getting random rubbish. So it might be an analog problem, not a digital problem. What's going on here? I haven't been able to find any digital problems. Nothing explicit, at least. Henry should be 10. Nothing there. They're definitely making contact. Then it should be blank. Out of range on. Yeah. Back around to there again. Now it's showing 0. But that should be over here as well. So dissipation is not showing. That means inductance, but okay. So that's in 120 kilohertz. Do 1 kilohertz. Right all the way around back to the beginning. So I'm in the right sequence. So that's showing 1. It should be showing 100. Should be showing 1000. Again, it should be showing zeros over here. That should be 10. That should be 100. No, no. These are the only ones that show correctly, which are ones which I thought were errors before. All right, so interesting. So capacitance with an open. Same process. So let's do parallel first. Yep, should be parallel, and we'll go through. It's PF. Should be showing 1000. Should be 0, 0, not. That's NF. I must have skipped the first step. It should be showing 10. Then it should be showing 100 now. Nothing. Should be showing 1000. Nothing there. Should be something there. No, let's go right around. I've bloody skipped a bit, haven't I? So PF, very first PF is what I need to find. That one there. So that should be 1000, which is zeros over there. That should be interesting. It says NF over there. Is it switching these? Is that what it's going? That's parallel. PF. So that one there should be 1000 with zeros there. That's right. Okay. Right. That's what's going on. NF parallel should be 10 with zeros. Should be 100 with zeros. Should be 1000 with zeros. It's not doing the right displays, which is interesting. UF should be 10 with zeros. Should be 100. Is that right? No, that should be blank. UF blank UF blank. Yeah. Did I miss one there? Hold on. UF. Where's MF gone? Oh, because I'm still at 1 kilohertz. I'm looking at the wrong bloody chart. Oh, you dumb bugger. Okay. Anyway, yeah, it's... Okay, I'll do this again. Dummy. Should be 100 with zeros, 1000 with zeros. Now looking at the right chart makes more sense. 10 with zeros, 100 with zeros, 1000 with zeros, out of range, out of range, out of range. That's correct. But it should be not showing the numbers it's showing. It should be showing one, beginning with 1. So that's not correct. There may be some other thing I've got to do. I don't know, maybe there is. And then 120 kilohertz, this should be 1000 with zeros. Should be 10 with zeros, 100 with zeros, which it isn't. 1000 with zeros, 10 with zeros, blanked, blanked, blank. No, that was it. Yeah, MF, blanked. Where's MF? If I skipped one, UF out of range, MF out of range, there we go. So that's fine. So this isn't showing what it should be, and that's not showing the right values, so I need to try and figure out what that means. There's another switch over here. Let's flick that. Nah, ain't that then. That's the different test switch. I know I've played with that before, but anyway. It's not right. That's all I need to know. Yes, it's just something's going on there. So I've kind of gone back to where I started from one of my earlier tests. Now this is doing test 2 again, but it's doing test 2 but failed test 2, so now I go back to doing test 1. I removed the A4, 5 and 6 cards, and what I have to do is test for correct levels on the A3, A7 and A8 cards. Some of these are going to be hard to find. Yeah, I might do it from the bottom of the board and try and do it that way. It might be easier actually to do it that way. So we'll go underneath. I was wondering which slot is which. It should be fine. It may even say on the bottom what they are. It bloody well does too. Some of them at least. It does. It's got similar signal levels down here. Wish I'd known it before. Might have been made it easier. Anyway. Okay. So what I want to do is find on the A3 card I need to find 4DL, sorry, 4L, DL and 5L. So 4L and 5L are going to be easy. I know where they're going to be. So the A3 card is this first one. So I need L, which is this side, and that's been 1, 2, 3, 4L. So that'd be 4L there. Right, let's turn it on. We have nothing at all. Nothing at all. Oh, that plug's loose. Yeah, I think it is. Okay, we have something now. So in capacitance range, let's make sure, yeah, we're in capacitance range just there. Let's try and get back in here so you can see what I'm doing. So 4L, yeah, digital signals there. Well, it was. Yeah, something there. That's fine. DL would actually be back on it. ABCD, so it'd be right there. Yep. And 5L is that one there. Yep, it's digital signals there. So it's sufficient apparently just to say, yep, there is or is not a signal. So now I need 3L as well. It's in the list, so let's check that one. Yeah, that was a high. Yep, there we go, that's switching. Okay. So 3L is also there, so that's all the left hand card done. So time to do the right hand section, which is under here, which is a bit awkward, but it is what it is. Be careful not to tear it off or something, because that'd be bad. Now, unfortunately you won't be able to see this. Now, what do I need first? I need first round is 3R, so third pin, right there. Well, as pulses this then, as I count it up, so yeah, that's pulsing fine. So I want 5R, which is that one there, which is marked. It's currently high. Is it going to change? It says high and low at each pin. Well, I'm not getting that. I want the correct pin. Hold on a minute. You dummy. You dummy. It's upside down. Oh no, I did get it right. It's left, that's right. No, that's okay. That's okay. Alright, I'll forget that. So, pin 3 should be doing some kind of digital signals, but oh, there's one there. There we go. If I did it. Yeah, that's fine. Alright. So that is 3. Okay, so next one I've got to do is on the A8 card. So this is 3R on the A8 card. A8 card is the one that's still in it. Is it? Or was it this one here? So 3R should be OFN, and it is actually marked on the boards here. So 3R. Well, there's some stuff marked on the boards, not everything. There's an OFN over here, which goes through to there, which seems to pass through, but isn't there OFN? Not in the right card spot though. We'll see if we get lucky. It's A83R. So that's 3, 4, 5, 6, 7, 8. 8. Right hand, pin 3. That one there. Alright. So yep, that's it. 5R we want as well, which is that one. Yep, there's also a signal there, that's fine. And that's that APA 1, which is super strong, and the AR, which will be that one there, which is also another one's super strong signals. So those all check out. Yeah, okay. Keep going. Okay, so the next part is as follows. A4 ball check apparently. Now I have to set it on capacitance range, which I've got set. I need to have it on parallel. I've got set. No connections on the front, apart from the jumper link, so that doesn't specify what to do with those, but I've assumed they're supposed to be made, so I've left them made. I have to observe the waveform at the HCUR terminal, which is this one. So I might as well stick it on that bar there. And there we go. So that is a waveform. Yes. Okay, now, although it's an awfully noisy waveform, there is a waveform. So next thing I'll do is check for does frequency change when frequency switch from 120 Hz to 100 1 kilohertz. Well, it's supposed to be 120 hertz, is it? Is it? Yeah, there's an awful lot of noise in there. It's a trigger. Trigger's way off the screen. Let's bring the trigger down. So there's so much noise in there, eh? So let's just see if I can get that a bit cleaner. Noise rejection on. Maybe helps slightly. Bandwidth limit. Stick that on 20 megahertz. It helps slightly as well. Not a huge amount. $50 ohm. Yeah, this kills it. So I'll do that. But I'm measuring 50 kilohertz there, not 120, which is interesting. But see, there's bloody spikes in there, which is, that may be a sign of a problem. I don't know yet. Anyway, so it's measuring a frequency. If I change this to 1 kilohertz, the frequency changes too. And the scope is having trouble reading it because there's so much noise. But yeah, it's let's increase the memory depth. Anyway, it drops down like that. Oh, gone too far. There you go. That may help. Peak detect. No, I don't want that. Alright. It's very noisy. I'm surprised by how noisy it is. I really am. I don't think there's really a lot I can do. I think I might leave that noise reject turned on actually. Maybe I won't. Leave it as it is. So yeah, it's changing frequency. I can't see what the frequency is. I suppose I could do it with cursors, couldn't I? Do a single shot. Cursors. Let's do. Where are we? That's right down there. So I want vertical cursor. Let's go from there. To there. That says 980 hertz. Okay, pretty much a kilohertz then. So yeah, that's alright. Do another single shot. And touch probe on there so I can see it. We'll do the same thing again. So let's verify this frequency here. It's a handy thing having cursors, so you can do it this way. That was the whole pair moving. Oh, I'll come back to it in a second then. Everything on back. Yeah, roughly. That is 120.7 hertz. So yeah, it seems the frequencies are correct at least. Right, back to normal. Now, turn the cursors back off. So now I need to check voltage levels. So that is supposed to be 50 millivolts or so. RMS is about, yeah, it's about 49, 48. It's jumping around quite a bit. 48. Yeah, thereabouts. 1 kilohertz is also about 48. So yeah, that's okay. The voltage level at that point looks alright. So I need to do a 1 volt level. So yeah, drop this down a bit. Because that's only 50 millivolts, so any little noise in there was showing up quite badly. It's been triggering up. There we go. So that's showing us a much higher frequency, interestingly. Strange. Anyway, so that's really 920 millivolts. If I change the frequency again, about 916 millivolts. So yeah, that's slightly lower than what it says. But then I don't have an earth probe on here, so maybe that will change if I do that. But you know, so those seem correct. So now I've got to do inductance, and I'll have to short those terminals again. So I have to do what? Function our short between there and here, and observe the waveform at A4 pin 6L. Ah, crap. Right, let's try it over again. It doesn't say what voltages or anything to have on there. Okay, well, it's got some other bits and pieces to look at there. So, all right. So A4 pin 6L. So that's A3, A4, L pin 6, which will be there. Yeah. Okay. What I'm looking for? Pin 6L. 6 left, yeah, pretty sure I'm at one. 3, 4, 5, 6. Yeah, that's 6L. Alright, well, we'll bring the level up. It doesn't appear to be much going on there. There is something, but it's very low. Change modes, change voltages, change frequencies. Yeah, I don't know. There's something, but I don't know what I'm supposed to be getting. It didn't actually specify. Aha, hold on. There's a little sub note there. Now this is different. Here we go. So this is supposed to be. So I've got a short there. Definitely got a short. We should be a short. I was reacting to it, so it must be working. I'm not getting that waveform. It shows a sine wave of 1.4 volt to a 2.8 volt peak to peak. Well, I'd say peak to peak, but it's a sine wave, so you assume that. So, and that's not what I'm getting. I'm sure I'm in the right place. Excuse the back of my head again. 13, yeah, definitely. That's 9, yeah, that's 76 there. 30 pin 6. That's not what's there. Then it says, hold on a second, perform self-test 2. Okay, self-test 2. Setting a switch. Is waveform a distortion-free sine wave within 1.4 volt to 2.8 volt peak to peak in amplitude for each measurement range? See photo. No, it isn't. It really isn't. Okay, well maybe I'll get my ground probe, wherever the hell I left that. That's a good question. Where have I put that? seem to have lost my ground clip from my probe. Oh, there it is. Hiding behind the soldering iron. Okay. I'll try grounding it and see if that makes a difference to it. Just in case it's upsetting things a little bit. 6, 4, 5, 6. Yeah, they didn't change anything. So that voltage is missing. It's really, really weak. So yeah, I mean, I should be able to see it there clearly, and it isn't there in any range, any voltage. No, it's not coming up at all. Doesn't matter what I'm doing. So it isn't there. So we have a clue. Protective diode check, apparently. Right. Move front panel from unit. Oh god. Unsolder full protective diodes connected to low terminals. Really? There's diodes in there? I didn't see any. I can see some stuff down there. I don't see diodes. I see some capacitors and resistors. That's interesting. Maybe we'll have to take the front panel off. That's a bit of a pain, but okay. Let's do that. Excuse me, I'm doing this freehand because of access, but I pulled the front panel off and I'll get the wire out of the way. You can probably see that there's a couple of diodes right there. There we go. Right, there's 2 diodes there. And there's 2 more under there too. Just there. So I'm going to have to check all those apparently. That may be something to do with what's wrong. Well, I decided rather than unsoldering these things, because they're just back-to-back diodes, I should be able to test them in circuit with them and take them out. We'll see how we go. I've already got the meter set up for it. So let's have a look. Okay, 0.65, that looks right. Other way, same deal, that's good. That diode pair looks correct. Check that one. Yep, that's okay. That's okay, so those diodes look fine. Doesn't appear to be that.